Now next important question we are having, by the properties we have to prove that left hand side is equal to right hand side. Okay, so let's start it. We are having now left hand side. Now what we want, how to start with applying the operations. Here we want x minus y, we want y minus z, we want z minus x. So when, how we can get it, that are the operations. Okay. So now we are having here x square yz. Okay. Now what type of operations I am going to use it? R2 approaches to R2 minus R1, R3 approaches to R3 minus R1. Okay, these two operations I am going to use it. Now it becomes minus of x minus y, then minus of x square minus y square and zx minus yz, then z minus x, z square minus x square and xy minus yz. Okay, so first type of operation I have used. Now I am taking x minus y and z minus x common from R2 and R3. So I got here x square yz. Now here it is minus 1, then using the identity it will be x plus y. 1x minus y has already been taken out, and taking common from here z, we are getting x minus y. Okay, then here it is 1, then z plus x, then taking common we are having x y minus yz, we have taken y common, we are having x minus z, so here it will be minus of y, negative of y. Okay, now next operation. Now I can easily make, by adding R3 and R2, one term can be 0. Okay, so we are having now x minus y, z minus x with R3 approaches to R3 plus R2. Okay, so we are having x square yz minus 1, because I am going to change only row 3, minus 1 minus of x plus y, then z as it is. Now 1 plus minus 1, that is 0. Now z minus x plus this one, we are having z plus x minus x plus y, and here we are having minus y plus z. Okay, so here we are having negative minus. Now x minus y, z minus x and z minus y common. Now this z minus y is common from R3. We are having x square yz with minus 1 minus x plus y z, then 0, 1 and 1. Okay, now expanding along R3. Now R3 we are having one term 0, 2 here is 1 and 1, so let's expand it by R3. Okay, even you can use this part also, this minus this or this minus this, to make one more 0. Okay, so need not to go for this. Now we are having x minus y, z minus x and z minus y. x minus y, z minus x and z minus y with, now here we are expanding this one. Now first is element is 0, so first is operation is finished. Now with minus 1, now minus 1, now we are deleting this row and this column. Okay, so what we are having after doing this minus 1, we are having this with this minus this with this. So minus 1 with y z. Okay, so let me write it like this first to make you understand in the more better way. We are having x minus 1 and yz with z plus again 1. Here we are having now x minus 1 x square with minus x plus y. This we have to solve like this one. Okay, so now what we are getting, x minus y, z minus x, z minus y with negative 1 xz plus yz plus 1. Now negative of x with x plus y plus x square. Okay, so further this becomes x minus y, z minus x, z minus y. Now minus xz minus yz minus x square minus xy plus x square. Is it clear? So we are left with now x minus y, z minus x, z minus y with minus of negative of xz plus yz plus xy. Now xz plus yz, yz plus xy plus xy. Okay, so finally we are having, now here it is negative. Okay, we are having x minus y, z minus x, to this part z minus y. If I am writing minus of z minus y, so we are getting y minus z with xz plus yz plus xy. Okay, so this changing this to negative and multiplying by this negative, it becomes positive. Okay, so this is our right hand side. This is equal to RHS, RS. Hence we have proved the question. Okay, proved.